Hi, hello everyone. I guess we should get started then. So, hello and welcome to our talk. This is Learn Some New Moves. We're going to be talking about some advanced Android animation today. My name is Nick Butcher. I am a design and developer advocate at Google, so I help people like yourselves design and build awesome Android apps, and I have a special focus on like animation and motion design. And I'm joined by
Doris. My name is Doris Liu. I work on Android UI Toolkit team. My primary focus is animation, and that includes AnimatedVector Drawable and the framework animation. That is the object animator and value animator, and that things in that realm. And then also the new physics-based animation library.
Awesome. And for those watching on the video, if you want to follow along with the slides, you can do so at this URL at j.mp/newmoves. If those in the room go there now, you'll be a little bit disappointed, but I have sat on the URL, so it will point to something soon. So yeah, today, motion design. We're here to talk about animations. And in my opinion, animation is a factor that can really help your application go from good to great. It can make you stand out in a crowded market. Here I'm showing an application which I work on, I build, called Plaid. And on the left, we have a version with animations enabled, and on the right, I've disabled animations. And hopefully you can see, not only does it feel a little bit less staccato with the animations, but also hopefully feels easier to use. Animation doesn't just add whimsy, and it doesn't just add delight and these kind of fluffy things. I genuinely think that animation can help guide users' focus. It can help ease their journey through the application. It can explain what they should be doing next or how they got to this state. So I think that animation is a really, really important part in kind of polishing and making your application really, really shine. Animation has been hard to build in the past. You had to do a lot of stuff yourself. You've had very low-level components, perhaps, that you had to reach around and plug together yourself. Things have gotten a lot better. There are new libraries and new tools and frameworks which you can use in your applications to achieve these kind of impressive motion design effects. So today, our goal is to take you through some of the latest developments, some of these tools that you should have in your toolkit in order to make your applications beautiful and utilize motion design. So let's go straight into it. The first of which is one of my favorite APIs, which is AnimatedVector Drawable. So here, from that very same app from Plaid, is a kind of little selection of AVDs, which I've created and using through the app. Hopefully you'll agree that they add a lot of character to the application. You can go from being something that might look bland or might kind of fade away in the market to something which kind of has its own feel, has its own personality, stands out, speaks to you. As well as that, I think they really ease a lot of the transitions, so a lot of state changes, in this, especially, so things like this following button or the little heart and so on like that, they communicate what has happened in the application. So I think they are kind of delightful, but they're also really, really meaningful. To understand how to build AVDs, you first need to understand vector drawable, so I'm going to take you through this quickly. So for those of you who don't know vectors, basically, it's an XML format for defining your images, right? So it's basically a vector element with one or many path elements within it. So the vector has a intrinsic size, much like a raster asset, like a bitmap might have an intrinsic size, or would have an intrinsic size, but it also has this second viewport size. So these numbers don't have to match. Basically, the viewport size is kind of, think of it as like the coordinate, or the canvas, or the coordinate space, which all the paths are defined in. So when you get these path data chunks like this, all these numbers are relative to this viewport size there. And what do these mean? Do people understand what shape that's drawing there, hopefully? Maybe you think it's not important to understand these numbers, but I really do think you should kind of have a kind of basic familiarity of what these things you're working with, and I'll tell you why in a minute. But when you take a look at those numbers, it's actually a really simple schema. So what it's saying, these numbers here, letters and numbers are saying, is pick up your pen and move it here, and then draw a line to these coordinates, and then pick the pen up and move it over here, and draw a line over there. So it's a really, really simple schema for just describing any drawing. And with these, this path data spec, you can do these moves, lines, curves, arcs, and there's various kind of variations for relative movement and so on and so forth. But basically, super primitive stuff with which you can build this up to draw literally any shape. A path itself doesn't actually show anything on screen. You have to stroke or fill it. So here I'm drawing a stroke, which is going to go around the outside of the shape, or you can fill it to fill it in the color. And crucially, notice that each path you can name, which is going to be useful later on. So beyond individual paths, of which you can have many, you can also group these paths together into groups. And the groups are useful for performing transforms onto them. So here you can set things like pivots in order to rotate or scale around that pivot, as well as like translating X and Y and so forth. Additionally, you can set clip paths on any group. So you can have one for the overall vector or one per group. You can't apply a clip path just to an individual path unless it's in a group. So the clip path defines the region within that group which will be drawn. So you can define a larger set of paths, but then only draw a subset of them. And we'll take a look at this in a sec. And the last feature of vectors is interesting is this trim path. So even if you define a path, which could be like a really long line or something like that, you can only draw portions of it. So for example, you had a line like this. If you set a trim start of 0, end of 1, that means don't trim me at all. But then if you change those numbers, so you set a trim path end of 0.75, it's going to draw the first 75%. Start of 0.5 is just going to draw from halfway to the 75% way, and so on. And then the last attribute is trim path offset, which takes those trim values and kind of offsets them. And you see this will actually wrap around. So if you kind of like do values like this, and these are going to be super handy when we come to animating these factors later on. Cool. Okay, everyone with me? That was a million-mile-an-hour tour of what you can do with a vector. So now we understand vectors. Let's animate some of these attributes. So an animated vector is actually kind of like a collection of free things, really, and it's actually 3 separate files that you have to create per animation. Well, sort of. So the animated vector, the first thing, is actually kind of a link between the 2 other things. So it defines a drawable, a vector drawable, which you're going to like animate. And it targets animations on each of those paths or groups of the drawable. So it defines one or many of these object animators which should animate a property. So here we're animating the rotation on a particular part of the vector. I say it's in 3 separate files. There's actually an alternative, which is called the inline resource format, which lets you specify all 3 of these things in a single file like this. And then it uses some AAPT magic. So at build time, AAPT will say, it'll grab this vector, it'll actually extract it out and like create a new file, and it will insert in a reference into the parent node there. So this can be useful because it can be less cumbersome to deal with a single file rather than multiple. But bear in mind, you don't always have to use this. Say, for example, if you want to use the same object animator, say you define one animator to run like a rotation, and then you want to apply that to multiple different targets, you might still use the classic, like, factor that into its own file rather than define it multiple times and have it be created multiple times. It'll be more efficient that way. So we understand the format now. What can you actually animate? The cool thing is you can actually animate pretty much everything of those attributes of a vector drawable we looked at. So on a path, you can do the color and opacity, the trims and the path. And on groups, you can do the translate, scale, and rotate. I used to have a slide in this presentation which said this was what was available on API 21 and above, and you couldn't do paths previously. But as of support library 25.3, you can now also animate path data in the compat library, which is awesome. So you get like path morphing stuff all the way back to API 14, which is pretty cool. So let's take a quick example of some of these. So this example here, which is an animation I run on a bottom sheet. So when it's expanded, I want to have an X to kind of dismiss it. And as you're dragging it down, I want a down arrow to encourage you to kind of flick it downward. And this is really simply achieved just by trimming these bottom 2 parts of the X. You can like make them retract, and then just do a translate on the group in order to kind of keep it centered. So simple stuff, build them all together, and you can create some fun effects. 2 of my favorite animations from that application is like this search button going into a back and this kind of upload progress going into a tick. If I overlay what the full paths look like, you can see that these are just like complete shapes, but by using those trim values, you actually only ever show a part of it at a time, and by like cleverly and like using good timing on the animation, you can make it trace out these shapes and kind of like perform the animation that you want to see. So again, it's like a deceptively simple API, right? Just trim a part of this path that you're going to show, but you can kind of yield some really kind of great effects, I think. Next up is on this heart one, so particularly on the break. So when you see it kind of like break a heart into 2 parts, and you see them kind of break apart, very sad, I know, and fade away. That's just simply like rotations on each of the halves of the heart, have a group and a pivot point, and you rotate them around, and then you animate the fill color in order to get the kind of fading out. Really simple stuff, again, builds up to be some cool stuff. And then onto what I think is kind of like the most interesting and most powerful is actually animating the path data itself. So each of these 3 examples are using path animation. So in the top one, the plus turns into a minus. That's a path morph. So the actual like coordinates we're drawing change from the plus coordinates to like the minus, with a rotation thrown in for good measure. The heart one, let's go that one next one. That's an animation of the path data of a clip. So when the heart fills up, when you see it like going up there, that's actually the clip is defining which area of the, how much of the filled heart you show. So we have a clip like the whole area, then you don't see any of it, and then you animate the clip downwards to show it filling up. And then the last one for this kind of eye visibility strike through type thing, if I put this red layer, hopefully that comes out in the projector here, showing. This is the clip path which is applied to the eye. So basically, only the areas covered by red actually get drawn. Anything outside of the red, outside of the clip path, won't get drawn. So by animating this path data itself like this, that's how we get the strike through. So that part of the eye is cut out, and then I just draw a line as well at the same time in order to get this kind of visibility change thing. So pretty cool. So going a bit more in depth in this, I think path morphing is one of the most kind of powerful and most interesting effects you can build. But it's also one of the most complicated. And to think about it, when you do a path morph animation, this is the kind of thing you're doing. So you're animating the path data property, and you have to give it these two values, the from and to, like from this exact path to this other exact path. And who here has seen this exception? Binary file exception can't morph from this to this. The reason is that it's a fairly simple system. Basically, we want to linearly interpret between each pair of points, so from the from shape and the to shape. So therefore, there's a requirement on you to supply paths which are like compatible, as we think of it, which means that they have to have the same number and type of drawing commands. So to kind of like, that's not very clear. That's just to kind of express what that means. Say you were going to draw path morph from a small square to a large square. They may have drawing commands like this. You can see that this has the same number and the same type of drawing commands, so this would be considered a compatible path, right? Everyone with me? But what happens if you want to do, say, from a square to a circle, or a square to a triangle, or a square to a weird clip path that makes an eye disappear a little bit? What do you do? Well, this is actually quite a well-studied piece of problem space. There's lots of literature, prior art on this, especially in the web area. And the kind of general idea is you need to make them compatible. So what you do is you end up splitting up the smaller path into subpaths such that they have the same number of points. So if we're drawing a square, we'd have to split the circle into 4 points. And then for them to be the same type of command, the command for drawing the arc on the circle is going to be the curve command. So even though the lines on the square could be drawn with a simpler line command, we'd actually draw them with the curve command. So we'd just draw a curve where you place the Bezier handles to make it draw a straight line. And you can get as fancy as you want with this. So if you add more and more points, you can get a smoother animation between these two states. Rather than having larger changes, you can add more and more. And it's kind of like a trade-off. But there's a problem with this, really. Like, how do you create these things? Like, Android just wants us developers to give it, more from this path to that path. It doesn't, you're not going to say, I want to go from a square to a circle, you figure it out. We have to kind of generate those. So how do we do that? And I think there's a few problems involved with this space. First off, when you're drawing the from and to states, you're normally probably going to use a graphics package. You're using Sketch or Photoshop or Illustrator or something, and you're kind of producing SVG, and then you're using an importer to turn that into vector drawable. This process, you don't really get much control over where the path points are. So for example, design tools don't really expose where the points are. So if I draw a circle in Sketch, I just get a center and a radius, right? It doesn't tell me there's 4 points here like this. Or sometimes you want to overlap the points, so you have them coinciding in the same place, such that you get a better morph at the end. But design tools don't like doing that, overlapping points in the same place. And it's also really hard to visualize the in-between states, which can be really important, because sometimes you can have compatible paths, but if they're in a weird order or something like that, you get these in-between states which are really awkward and can look horrible. So basically, the current tooling isn't great for doing that, but luckily there's a new kid on the block who's been really awesome. So who's heard of Shapeshifter? Big fan of this. So this is a web tool for those who aren't familiar. I've got the URL coming up at the end, which is going to help you with these problems. So here's an example from we looked at earlier when I'm going to morph a plus to a minus. So I've got two SVGs I created. Go back. So yeah, here we go. I've got two SVGs which I created earlier, and I just drop them in and add them to my canvas. So for those who haven't seen, it's basically a web-based IDE for creating animated vectors. In previous talks, I've like shown people how to hand write XML, like how to write animated vectors, which is kind of how I learned it. But please don't do that. Like this is a better way. Like we have good tooling now. I really think you should be able to read that XML. Like I really think you should be able to go through it and like be able to code review your peers when they submit them and so on. So you should understand it. But like this is the way you should be writing it. It's a very animation is a visual thing. I think we should be using a visual tool. Right, back to our path morph. So I dropped these two paths in. You can see that one is a minus, one is a plus. If I go there and I just grab that path data and then copy it to clipboard and then just delete that because we don't need the two versions. And then if I click on that little, if you didn't see it, there's a little kind of clock symbol. Click on that, and these are the different animations. So on the path here, I can do like a path data, fill, colors, blah, 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 all those things we looked at. So if I go and add a new path data animation to it, I'll get an entry on the timeline, and I can set a duration. And you can see the from and to values right now are the same, so it's going, the minus to the minus. And if I just paste what I copied on the clipboard into the plus path, so that's the path I want to go to, and it's giving me this helpful little warning. It goes really red and angry at you, and it tells you that these are incompatible. It offers you this tantalizingly tempting magic wand to fix it, but we're not going to press that. We're going to go into the little pen tool up here to actually go into this kind of like morphing thing. So this is kind of like a detailed view of what's going on. So if we look here at our shapes, we can see that I'm trying to go from this minus, which has 1, 2, 3, 4 points, to a plus sign, which has like 12 Bezier points on it, and it's saying that's not possible. So what I'm going to do here, oh yeah, look, see, 4 points, 12 points, there we go. I am going to click the magic wand thing here. So if we do that and just pause there, if you look at the minus, you can see that these red dots in the middle, these are the ones that have been inserted. So this is what we're talking about, like inserting extra points in order to make these things like compatible. But just because there are the same number and the same type of command doesn't mean it's going to be a good morph. I actually gave it SVGs in a particular format in order to trick it. So that when I do this, when I have a look at the timeline, look at the middle guy, that's a pretty horrific morph. So just because it has the same number and type of commands doesn't mean it's going to be good. What's going on there is actually, if you look at it, if it comes out on the screen, but basically the minus is created with points from the top left going clockwise, and the plus is like from this left kind of point going anti-clockwise, counterclockwise. Sorry, I'm in America. So because of that, the paths are all kind of like going to go. This one's going to go over here. This one's going to go over there, and it kind of looks pretty horrific. But Shapeshifter's got your back once again, so you select it, and you hit this little rotate, refresh type icon, reverse points, there we go, and it's just, if you saw it quickly, then the points will change numbers, so it's now going clockwise. I'm okay here because the 1 and the 1 are in the same point, but you can also use these shuffle points, or you can select one of them and hit a button up there, we'll say number 1, and choose where it starts from, so you can reorder the points. So in Sketch and stuff like that, you can reverse path points, which is pretty easy, but you can't shuffle them around, which is actually quite handy to do when you're thinking about this morph type situation. So pretty cool. And then when I do the morph, you see it looks a bit, okay, it's better, it's not going crazy, but that's not actually what I want, because you see it's just like taking a best guess and evenly spaced out these points. But it's giving me this kind of like fat plus, which I'm not really like too into personally. So what I do is you can actually just grab these points on the left-hand canvas, and you can just drag them around. So I'm going to overlap them, which again, this is that thing that I said is almost impossible to do in drawing tools, because it doesn't like having multiple points in the same location. But then that's what I wanted. I wanted to have this plus to minus animation like this. And voila. So once again, shapeshifter.design is the URL for this really, really cool tool. And the guy who builds it, Alex Lockwood, is actually at the conference, although he said he wasn't going to come to my talk. So you can give him some stick for that, please. So yeah, buy him a beer, perhaps, if you find it useful. What was I going to say about Shapeshifter? Oh yeah, this actually came about because I was having a conversation with Alex and Roman, and I started writing a blog post about how you do path morphing, and I got halfway through it and I said, this is too hard. like why am I like hand coding SVGs like an animal? Like it should be better. And kind of like we got together and mocked up some designs, and Alex actually did all the hard work and built a web tool. So him and Roman deserve all the praise. But this is like super awesome. So yeah, thank them. So that was a crash course in AVD, and now to Doris about behind the scenes of what's going on.
All right. So today I'm going to take you behind the scenes to see what we have changed to AnimatedVector Drawable and Vector Drawable. So for Vector Drawable, in Android N, we rewrote the entire Vector Drawable in native. And then with this massive rewrite, we have seen some significant performance improvement. And along with many of the optimizations, we're now seeing 80% faster on path parsing. And this is important because path parsing happens during inflation, and inflation involves lots of work, such as loading resources and parsing resources, creating necessary data structure, creating view, adding views to the view hierarchy. And all this work may or may not be done within 60 milliseconds. And making path parsing faster is one step towards hitting that 60 millisecond frame deadline. In the meantime, we also improved the path morphing by about 40%. And then for AnimatedVector Drawable, in NMR1, the biggest thing we did is we moved AnimatedVector Drawable onto render thread. And some of you might find render thread somewhat mythical because there isn't a lot of documentation around it. And that's because render thread to us is considered more of an implementation detail than a public-facing feature. And simply put, render thread is just a background thread that is responsible for generating frames. And render thread has cached draw commands that were issued from the UI thread. So that means render thread can draw frames without the participation of the UI thread. So by moving AnimatedVector Drawable onto render thread, we're able to continue to animate the AnimatedVector Drawable even when the UI thread is stalled. So here's an example that really drives home the benefit of moving AnimatedVector Drawable onto a render thread. Here I have the same app running on two different releases. On the left is running on N, which had the old AnimatedVector Drawable that was running on render thread, the UI thread, sorry. And then on the right is running on O, which has this render thread blessed AnimatedVector Drawable. And inside the app, on the top part is just the progress bar, very standard, no customization. And on the bottom is a recycle view that has some artificial jank injected in it to purposely slow it down. And then as I scroll the recycle view, as you can see, the recycle view is really struggling to produce frames. And but if you pay attention to the progress bars, you'll notice on the right, the progress bar on render thread continue to animate at a high frame rate. And in contrast, the progress bar on the UI thread is dropping significant amount of frames. And why is that? To answer that question, we need to take a look at the systrace. Here is a snapshot of the systrace. For those of you who are not familiar with this, you can see there is a UI thread category, and then there's a render thread. In the UI thread, we see a lot of work being done on UI thread. And you can see there's the work for recycler view, unbind view in the form of these green little blocks that are taking quite some time. And then, so as a result, from beginning of the frame to the end of the frame, which is once this frame is produced, it takes about 110 milliseconds, and only one frame is produced. And in contrast, here's the systrace for when the AnimatedVector Drawable is running on render thread. And we see, similarly, here we have a lot of unbind view for recycle view. And then the whole frame takes about, or the whole thing takes about 100 milliseconds. But the difference is, in the meantime, we're seeing 5 extra frames on render thread. And why did this happen? The reason being, since render thread knows that there is an animation that's running on render thread, so it will wait for a certain amount of time for UI thread to give it a signal to sync. And if it doesn't get the signal within the allotted time, it will decide to just go ahead and draw a frame, assuming that there's some jank on the UI thread. And then when the next vsync comes around, it will just do the same thing. And then in this case, after 5 frames, eventually we received a signal from the UI thread. But within this 100 milliseconds, we've managed to draw 6 frames, which is about 16 milliseconds per frame. That's a fairly high frame rate. And if we put these two systrace snapshots side by side, we can see on the bottom here, even though UI thread has been janky the whole time, we have render thread keep producing frames at a really high frame rate. And this is critical for keeping a smooth AnimatedVector Drawable, even when the UI thread is stalled with lots of work. And the best part is this comes for free if you have apps running on NMR1 or later releases using AnimatedVector Drawable or AnimatedVector Drawable Compat. There's nothing needs to be done on the app side to take advantage of this newly improved AnimatedVector Drawable. So after we talked about what you can get for free, if you're still looking for more ways to make your animations more efficient, here are some considerations. If you're animating alpha, then the least expensive way is to animate the root alpha of the AnimatedVector Drawable. And the reason for that is we cache the vector drawable in a bitmap without alpha being applied. So when you change the alpha, we simply need to just redraw that cache onto the canvas with a paint with a new alpha set on it. Whereas if you animate fillAlpha or strokeAlpha, you would need to invalidate the cache and recreate the cache, and that's obviously going to be more work. And if you're going to animate shape, the most efficient way would be animate the group transform, because in NMR1 and later releases, we've improved the caching to the extent that we're caching all the paths. When you animate group transform, we don't really need to invalidate the cache for the paths. We can just reuse that, and then just as we draw, we just apply the transform onto the path. And whereas if you do path morphing or path trimming, then we obviously need to recreate the paths. And so in this example that Nick mentioned earlier, there are obviously different ways to achieve going from left to right, but animating group transform would be the most efficient way to do it. Granted, sometimes animating root alpha or group transform simply can't take you to the effect that you're looking for. And in that case, my advice would be do what you got to do.
Cool, thank you. So we had a little look at AnimatedVector Drawable, the native platform kind of vector animation type. But there's a new kid on the block who piqued my interest called Lottie. Everyone heard of this? This is a pretty interesting looking library. So this is a vector animation kind of library, like workflow from the fine folks over at Airbnb. So thank you to them for open sourcing and sharing this. So it has a similar promise. It promises to bring very complex vector animations very easily onto your device. And one of the things I absolutely love about Lottie is the workflow. So for anyone who hasn't checked it out, the way it works is it's actually kind of like a tool chain based on After Effects. So After Effects is like Adobe's like motion design tool, and it's pretty much the industry standard for any like serious like motion design work. So motion designers work in After Effects, and they produce their After Effects files, and then they install this body move-in plugin, which is an After Effects plugin, and that gives you an export button, which lets you export your After Effects composition into a JSON format, a JSON representation. And you take that exact JSON, and there's players for the web, but what Lottie is a player for Android, and also React Native and iOS, I believe, but I don't really care about those platforms. So you drop the JSON file into your assets directory of your application, and then you include like the Lottie library as a Gradle dependency, and then it gives you like a Lottie drawable and a Lottie animation view, which you can just drop into your view and just try it out. So this workflow is pretty amazing because basically it allows serious motion designers, like incredibly talented people, to make their crazy, complicated After Effects files. And Lottie also supports like an absolute ton of things that After Effects can do, because After Effects is a behemoth, it's a monster. And Lottie does a pretty good job of supporting many, many of them. I was part of the team earlier this year who worked on the Google I/O app, so sorry if it crashed for you. But part of that was these big animated headers. If you were lucky enough to be at I/O or look at the website, you would have seen the slashes were everywhere. It was like branding crazy. And this was part of the app design, so we had some motion designers creating these animated headers and so on. And they were working in After Effects, so it seemed like a no-brainer to like try Lottie out. And so they kind of exported their compositions straight from After Effects into this JSON format. shipped them over to the dev team, and we literally just dropped them in, like included the Gradle dependency, included the view, pointed it towards the right animation file, and hit run. And I was like, that's the easiest animation I've ever implemented in my life. This took me like 5 minutes to get all of these animations into the app and running. And if you've ever done that with like other means, then that's kind of astonishing. So a big amount of respect for them for that. One other thing that Lottie can do, which AVD can't, is because AVD is kind of like fire and forget, the API surface is basically start and stop. But Lottie lets you kind of like control the progress. So here's something I hacked up, which is on the last screen, we've got these 4 subtabs. And so I kind of like tied that up to the animation progress. So as you swipe through the progress, I have swipe through the view pager. I have that kind of like controlling the progress of the animation. Which was like laughably trivial to do. So you just get a view pager and add a page change listener, and then as you scroll, you just transform that progress basically from 0 to 1 for the number of pages, and then just call the Lottie animation view has this set progress method, which passes it straight through to the drawable. And so you're just kind of controlling the progress through the animation. So you can get these fun effects. The Lottie demo has a nice one where you're doing like an onboarding wizard as you swipe through like an onboarding type thing. It controls an animation behind it. It's kind of cool. Like, so you can, if you're trying to build something like that, Lottie can be a good solution. I actually wrote up some more thoughts on Lottie on a Medium post, which I'll link to later. And as I said there's a lot to like. There was a lot of things that I really, really liked about Lottie, but there's also, it's not a silver bullet. We ended up not using it for a lot of the animations in the I/O app. We actually did ship some of them as Lottie animations, but for those big headers, we actually ripped them out and ended up doing that as AVD because we found the performance wasn't working for us. We were exceeding our frame budget, so we're getting frames dropped somewhere. But what I want from people to take away from this is tools, not rules. So don't take away from this that Lottie is bad and AVD is good. Take away from this that each have different performance characteristics and are good at certain things. So for some of the animations that we shipped, they were crazy complicated. And I wouldn't want to re-implement those as AVDs because it would take forever. But a motion designer working in After Effects was like super important to those compositions. So in that case, Lottie worked out really well. For something where performance is absolutely crucial, or say it's something tiny. So say you have a recycler view, which each of them has like a heart button, which is animated. But that's going to be however many instances of that view in your hierarchy. Something like an AVD is going to be way more performant and lightweight, rather than like instantiating a Lottie every time for that, even though they have some cool caching and stuff like that. So basically, don't take away like don't do this, do this. I'd say know your tools and know which is the right one for the right job, and profile your code. And also, I shared that post, and this chap, who turns out to be the author of the body moving plugin, piped in and said, oh, that looks interesting, and said, wouldn't it be nice if we could export straight from body moving to AnimatedVector Drawables? To which I said, yes, it would be very nice. So maybe watch this space. And while we're talking about the Google I/O application, there was another little interaction which I thought was pretty cool to share with you guys, which was part of the app. We have this feed, this recycler view of items, which you can toggle from like a collapsed into an expanded state. So I will show you how we made this, and it's almost laughably simple how easy it is. I feel kind of guilty again. But this is basically using one of the cool features of ConstraintLayout coupled with Transitions Framework, Transition Manager, basically. So what we do here is you have 2 layout files defining the collapsed state and the expanded state. So in the collapsed state, the image is small and the text is next to it. Expanded state, the image is full width, text below, you get the picture. And then what you do in your view holder of your item, you basically construct these things called constraint sets. So constraint set, think of it as just the positional information inside your layout. So your layout basically does 2 things. It tells you where to put the views, but it also binds data to it. You can link images and you can put text in there and so on. So constraint sets will basically just capture the positional layout information. So we inflate the view in the recycler view in the collapsed state. So what we do there is we call the collapsed constraint set and just clone it from the layout. So that's capturing the positional information in the collapsed state. And then we do something similar, but we point it at the layout file of the expanded state and populate that expanded constraint set. So we have this kind of like layout information. And then later on, so basically when you click the kind of header item, we just do 2 lines. It's like embarrassingly easy. You just say transition manager, begin delayed transition on the constraint layout. And then you do constraint set and apply to constraint layout. So expanded set, apply to that, or vice versa to toggle it back the other way. And that was it. So literally you define the 2 states, you use the transition manager, and then you switch between them. And you get what I think was actually quite a nice little animation, basically for free. Back to you.
All right. So we've introduced the physics-based animation library earlier this year. And the goal for physics-based animation library is to create continuous motion that is natural looking. And the key to a natural looking motion is to use a physics force to govern the movement of the animation. And then based on this force, we can then calculate the acceleration or deceleration, F equals ma, if you can still remember that from high school. And then we can then use the acceleration or deceleration to update the values and velocities of the animation on each frame until finally when the force reaches equilibrium, and that's the end of the animation. Fling animation is one of the animations that we've introduced inside of this physics-based animation library. And as the name indicates, it's usually triggered by a fling gesture, and then it will start with the same velocity as the fling gesture, and then being influenced by a friction force, and then eventually it will slow down and come to a stop. Here is a demo app. This is not the Google Maps app, even though it looks very similar. But it has a very similar bottom sheet that I think it would be interesting to play with. Here, for the bottom sheet, as you can see, I'm flinging it up, and it goes and carries over that momentum of my gesture, and then it slowly comes to a stop. To create such a fling animation, here's what you need to do. You need to supply to the constructor of the fling animation the object that you want to animate. In this case, that's the bottom sheet, and that is actually a view, but that's not a requirement. You can pass in any arbitrary object, and then the translation y of the bottom sheet as the property that we're going to animate. And then in order to carry over that momentum, we need to set the start velocity to be the same velocity as the fling gesture. And then we can set mean value and max value to constrain the range of the translation y change so that the animation never flies beyond its bounds. And now we're ready to start. So this is all it takes to create a fling animation. One of the things you can change to change the look and feel of your animation is friction, and you can do that by using the method setFriction. And here's a comparison between two different frictions. And as you can see, with a higher friction on the right, the same starting velocity would slow down much faster. And on the left, with a smaller friction, the bottom sheet would animate for a lot longer, covering a lot more space. And you can fine-tune the friction to your liking until it looks great for your app. The default friction is 1. In addition to fling animation, we also introduced spring animation. And here are some basics. To create a spring animation, you need to supply to the constructor of the spring animation the object and then the property for the object. Here, we're using a view and a translation y as the property for the animation. And then the third parameter, 0, that is the optional resting position of the spring. And in this demo, there are 2 parts to it. The first part is just a gesture that's pulling the little droid out of its resting position on top. And then once the finger lets go on the bottom, that's when the animation actually starts. And then as you can see, the spring force is pulling the droid back up to its resting position. And then you also see a little bit oscillation on the top there, and that's because this default spring force that we use has that characteristic. And if you want to change the way it looks, you can do so by changing the damping ratio of the default spring. Here I'm changing it to no bouncy, and you'll see an animation that's not bouncy at all. And this is very useful for apps that are more serious. Like, I wouldn't want to see a lot of bounces in my, say, bank app. Alternatively, you can change it to high bouncy, and then you'll get a very hyper animation. No judgment. That's just whatever works for your app. And then in addition to damping ratio, you can also change the stiffness, which is the other spring constants. And we'll talk about that in just a moment. And before we start the animation, we can also configure the starting condition for this animation, such as the start value. If you set the start value, the animation will always start from that position. And you can also set the start velocity so that the animation will match whatever motion that's leading up to the animation. And then you can set the min and max value to constrain the range of the animation. And now we're ready to start. So here we have different stiffnesses from low to high. As you can see, as the stiffness gets higher and higher, the animation goes back to its resting position much faster. And here are the 4 predefined constants for stiffness. You can use any of these 4 based on the, which look you like the best, or you can, based on that, fine-tune the actual value, and then use some value that's in between any of these for your particular app. So now let's take a look at a more real-world example. Here we have 4 icons on the top, and I'm having this animation to animate them in, to pop them in, and then they will grow and shrink, and then oscillate a little. I think this looks very playful, and in the same time, it really draws your attention to those icons. And this is useful when your app has some not so easy to discover features that's hidden behind a button or some sort of icon. You can give this a try. To create an animation that achieves that effect, we could just create spring animations on the scale X and scale Y property. But since I was told this is a more advanced crowd, here's a more advanced way to do it. Here I'm creating a custom property scale, which is more of a uniform scale. So whenever this scale changes, I want to change the scale X and scale Y simultaneously. To define such a custom property, we need to define the setter and getter. In the setter, whenever the scale changes, I want to apply that new scale to both the scale X and scale Y property of the view. And then in the getter, since we assume scale X and scale Y will change at the same time, and there will be always equivalent, so I'll just return scale X. Now that we have the custom property, we can then iterate through the list of icons. And for each icon, we'll be creating one spring animation on its uniform scale property. And then that last parameter, meaning eventually we want that scale to be 1 when it's resting. And here I'm also going to fine-tune the spring constants. Here I like a low stiffness spring, so the animation wouldn't finish too fast. And then for the damping ratio, since I sort of like the look of a high bouncy damping ratio and the medium bouncy, so I'm using something in between after some experimentation, which I encourage you guys to do. And then now I also need to set the start velocity so it has a starting point and before I start. You may also notice there is a set minimum visible change here, and that's something we haven't showed before. What this does is it gives the animation system a hint as to what would be a good threshold for the animation to stop. And as you know, the animation system can animate things like scale, which is usually between 0 and 1, or it can animate pixel-based properties like translation, which can go anywhere from 0 or negative number to 2,000 and plus. So there is not a threshold, a magical threshold that's good for all these different cases, which is why we need to provide a hint. And in this case, we're saying we want the minimum visible change scale as our mean visible change. And this is the equivalent of saying, here's the value that you can use so that when the value change goes below this, and you can just consider that the animation is no longer making visible change on screen. Therefore, you can stop to preserve batteries. So now we've seen the spring animation and the Fling animation individually. What would it look like if we combine these two? Let's take a look. So here's that same Fling animation that I've shown before, and except as I fling it up and it hits the bounce, you see it bounces a little bit up on top there, as if when the bottom sheet is flying towards the bounce, all of a sudden it hits a spring, and its momentum is pushing the spring and compresses the spring, so the spring then starts pushing back. That's basically almost exactly what's happening here. We're going to use the same Fling animation as we did before, except this time we're going to add an end listener. And in this end listener, we'll receive a callback once the animation finishes. And we know there are two different scenarios that a Fling animation could finish. One is when it stops naturally, meaning the velocity reaches 0, or when it hits the bounds that we have defined with the set min value and set max value. And to filter for the second scenario, we're going to do this check. We're going to check its velocity, and if its velocity exceeds a certain threshold, we consider that there's still some momentum left. And we want to have a spring animation to carry over that momentum. So we're going to create a spring animation for the bottom sheet on its translation Y property, same as the Fling animation. And then we want it to eventually rest at the bound. Now, we want to set the start velocity for the spring animation the same as the ending velocity of the Fling animation, so that that velocity seems continuous. And then we're ready to start.
Anyone who's tried to maintain velocity with object animator APIs, that's so awesome that you just do it so easily. I've done this before and it's horrible. The physics-based animation library is available now, and it has been available for a few months now. The spring animation was introduced first in support lib 25.3, and the Fling animation was introduced later on in 26.0.0 beta 1. To use the animation, you need to add this dependency to your Gradle file, and the animation library is backward compatible to API 16. Cool. So I think we're out of time, but just to wrap it up. Use motion, it's great. It makes your app better, more fun, and more understandable, better for your users. Use the right tool for the job, so understand these tools, these libraries that we've talked about today, know which one to reach for. And lastly, look at these new libraries for creating more natural motion. They actually do look really, really natural and really great. So thank you very much for coming, and these will be available online, and we'll be outside taking questions for live participants. So thank you very much.